Welcome to the worked answers for the Edexcel Calculator Foundation paper from June 2013. Now for this paper you can use a calculator, but remember it's still important to show your working out. As in every math exam, there is a formula sheet which you may or may not need to use. Just remember it's there if it's needed. Okay, answer all questions. Write your answers in the spaces provided. You must write down all stages in your working. Question 1. Write the number 2085 in figures. 2085 in figures. Notice there's a 0 because there are no hundreds. Write the number 5108 in words. Now the easiest way to do this is write as we speak. So 5108. So 5108. And notice I've used words all the way through, no numbers. Write down the value of 9 in the number 2.96. Okay, well our 2, that's our units. Now the other side of the decimal point, the 9, well they're our tenths. And the 6 is our hundredths. So in this case, the value of the 9 is 9 tenths. Write down 157 correct to the nearest 10. Well, 157 lies between 150 and 160. Now, it actually lies closer to the 160. So therefore 157 to the nearest 10 is 160. Question 2. Complete this table. Write a sensible unit for each measurement. Now in our table we've got metric and we've got imperial. Now metric measurements, they're seen as the new ones, the ones we use nowadays. Imperial, often referred to as old measurements, the ones that your parents might have used. So the length of a pencil. Well, the new measurement would be centimetres. That's what we would measure it in these days. But time past, they would have used inches. The weight of a tomato. Well, time past, ounces is what they'd measure the weight of a tomato in. But nowadays, we would measure the weight in grams. The amount of milk in a bottle. Well, it used to be measured in pints. But nowadays, we would measure it in litres. Question 3. Now this question is all about angles. So before we start, I'm just going to run through the different types. First of all, we have an acute angle. Now this angle is less than 90 degrees. We then have a right angle. This angle is exactly 90 degrees. An obtuse angle is the next one. And an obtuse angle is greater than 90 degrees but less than 180. Then we have a straight angle. Now a straight angle is 180 degrees exactly. Then we have a reflex angle. Now a reflex angle is greater than 180 degrees but less than 360 degrees. These are the most commonly used angles, especially in exams. So on this diagram, mark with the letter R a right angle. So I look at my diagram and I can clearly see in the bottom left corner there's a 90-degree angle, a right angle. So I mark that with a little what appears like a square and not forgetting to put the letter R. What type of angle is angle X? Well, here's angle X. And it looks quite small. In fact, it looks to be less than 90. And on my list, an acute angle is less than 90 degrees. So I write acute there. What type of angle is angle Y? Well, angle Y seems to be very big. It actually seems to be more than a straight angle, and it looks to be greater than 180 degrees, but less than 360 degrees. So if I look across, I can see that would be a reflex angle. AB is a straight line. So here's our straight line, AB. Draw a line from the point T perpendicular to the line AB. Now our line has to go from T, but it must be perpendicular. That's the key word. Now perpendicular means at right angles to. For example, when you walk along the street, you'll see a lamppost. So here's my street and here's my lamppost with my light on. The lamppost is perpendicular to the street. It's at 90 degrees. It sticks out of the ground at 90 degrees to the street. So our line has to come across and be exactly 90 degrees. So you need to take your ruler and you need to place your ruler on and draw with a pencil, just in case you get it wrong and you need to rub it out, a line that is perpendicular to AB. And you should get something that looks like this. Question 4. Simplify m plus m plus m plus m plus m. Now if we imagine these are Maltesers, we've got 1, 2, 3, 4, 5 Maltesers. So another way of writing that would be 5m. Simplify 2p plus 7p. Well, in this case, we can imagine they're pairs. We've got 2 pairs and we're adding 7 pairs. So altogether, we've got 9 pairs. And simplify t times w times 4. Now in algebra, we don't use the multiplication symbol. So we put the letters next to each other in alphabetical order. So tw is t times w. And the 4 always comes before the letters, so any numbers will come before the letters. Question 5. Here is a pictogram. It shows the number of boxes of chocolates Mr. Fenn sold last week from Monday to Friday. Now at the side we've got a key, and that key tells us that a large rectangle, which is made up of 4 smaller ones, represents 20 boxes of chocolates sold. Now it'd be useful for us to know what one of the rectangles is worth. Now if all 4 are worth 20, a simple bit of division, 20 divided by 4 gives me 5. So I know that a small rectangle is worth 5 boxes. Now what fraction of the total number of these boxes of chocolates, so that's for the total week, did Mr. Fenn sell on Tuesday? So we need to know 2 things. Firstly, we need to know how many he sold on Tuesday. And secondly, we need to know how many he sold altogether. So I'm going to work through each day and calculate how many he sold for each day. So Monday, he sold 20 and 10, giving him 30. On Tuesday, he sold 20 and another 20, giving him 40. Now on Wednesday he sold 20, 20 and a 10, so that's 50. And on Thursday he sold 20 and 5, 10, 15. And 20 plus 15 is 35. Now on Friday he sold 20 plus 20 plus 5, giving him 45. Now if I was to add all of those up, remember this is a calculator paper so you can use it if you wish, but if you add them up you will find that they equal 200. So altogether in the week, he sold 200 boxes of chocolates. Now on Tuesday, Mr. Fenn, he sold 40 boxes. And as a fraction of the total week, it's 40 out of a possible 200 boxes that were sold. Now there's no need in this question to simplify that. So I can simply put my answer as 40 over 200. Question 6. The line OP is a radius of a circle, centre O. Draw accurately the circle. So here's my line OP. Now it's telling me that the centre is at O. Now for this question, you are going to use a piece of equipment called a pair of compasses that look like this. Now with your pair of compasses, you need to put the point at the end of the line O, open it out so the pencil is at P, then draw the circle as accurately as you can and you'll end up with something that looks just like this. Part B. On the circle below, draw a chord. Now a chord is simply a line that goes from one side of the circle straight across and touches the other side. Now a circle has many different chords. Some chords can pass through the centre, but some do not. A chord that passes through the centre is actually called the diameter, and the diameter is the longest chord that a circle can have because it passes through the centre, but your chord can look anything like one of these. Question 7. The diagram shows the distances in kilometres between some towns by road. So here's our diagram. Work out the shortest distance between Amble and Ford by road. Well, let's have a look at the main routes that we can take. We can go through Branning, Colton and then on to Ford. We'll call that route A. We can go through Ditton up to Colton and then on to Ford. We'll call that route B. Or we could go through Ditton down to Everley and up to Ford, and we'll call that route C. So what we need to do is simply work out the distances for each of the routes, A, B and C. So A, we've got 30 kilometres, then 70 and then 20, and that gives us 120 kilometres. B, we've got 50 kilometres plus 40 kilometres plus 20 kilometres, and that gives us 110 kilometres overall. And finally C, we've got 50 kilometres plus 10 kilometres plus 60 kilometres, and that gives us 120 kilometres as a total distance. So looking at the three, we can clearly see that route B is the shortest at 110 kilometres. Question 8. A equals 4B. Work out the value of A when B equals 3. So what we have to do here is we have to substitute our value of 3 for B into the formula. So we're going to replace the letter B with the number 3. Now remember that 4B means 4 times B, because when you have a number in front of a letter in algebra we don't actually write the multiply in between, but it is there. So A equals 4B. So A is equal to 4 times 3, because remember I've replaced the letter B with the number 3. So 4 times 3 gives me A equals 12. P equals 4D minus 3. Work out the value of P when D equals 2. So in this case I'm going to replace the letter D with the number 2. Remember that it's 4 multiplied by D. So P equals 4D, take away 3. Well, if D is equal to 2, I've got P equals 4 times 2, take away 3. And remember BODMAS tells me that I need to do brackets first. So 4 times 2 is 8. Then I can subtract my 3 and it leaves me 5. Question 9. Work out the difference in value between 1/4 and 30%. Well, the key thing for this question is knowing that 1/4 is equivalent to 25%. So the difference is simply my 30% take away the 1/4, which is 25%, and it leaves me 5%. Now you can either express your answer as a percentage, or as a decimal, or as a fraction. Any of those three would be correct. Question 10. Kitty and George sell cars. The table shows the number of cars sold by Kitty and by George in the first 4 months of 2013. Show this information in a suitable diagram. Now for this question, a suitable diagram would be a bar chart. That way we can compare directly Kitty and George, and also it accounts for the fact that the data we've got is discrete. And remember that when we do our bar chart, we leave gaps between each month because the data is discrete. Now, if I move down below, you can see I've already drawn the axes in. I'm going to have frequency up the side and months along the bottom. So remembering that my frequency has to account for all the data. so it needs to go up as high as at least 13, because the maximum is 13, and that's for Kitty in March. So 0 to 14 is perfect. Now I can label that axis frequency, so that's how many cars are sold, and then along the bottom we can have months. So they're going to be the two bars, Kitty and George, for January. Then I leave a gap, and then we're going to have February. Then I leave another gap, we're going to have March, and then leave a gap, and we're going to have the two bars for April. Now the reason I'm leaving gaps is because the data is discrete. So label that axis months, and then we can set to work at drawing our bars. So let's look at January for Kitty and for George. Kitty, she sold 2 cars, and George, he sold 4. In February, Kitty sold 5, and George sold 7, and so on. And what you'll find is, because you're drawing yours with a ruler and a pencil, it's going to look much neater, and you're going to get something that looks just like this. Okay, so we've drawn our bars, they're nice and neat, and now we need to just distinguish between Kitty's bars and George's bars. So what we need is a key. So we'll have Kitty and George, and then perhaps we can use a little bit of colour, and we can end up with something that looks like this. Question 11. Here is a list of numbers. So we've been given the numbers 11 right through to 20. From the list, write down a factor of 24. Now the word factor is telling me that I'm looking for numbers that go into 24. So if I look through my list, 11 doesn't go in, 12 goes in because it goes in twice, 13 doesn't, 14 doesn't, 15 doesn't, no for 17, no, so it's just 12. A multiple of 7. Now multiple is anything in the 7 times table. Well, looking along my row of numbers, I know that my 7 times table, well, 2 7s are 14. 3 7s are 21, and it's not on the list. So the only answer there is 14. A square number. Now remember, square numbers are found by multiplying numbers by themselves. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. So these are the square numbers, 1, 4, 9 and 16. Now looking through my row of numbers, I can see that the only one that is there is 16. So 16 is my answer. Question 12. Here is the number of goals a hockey team scored in each of 10 matches. So here are our number of goals in the 10 matches. Find the median. Now the median is one of our averages, the other two being mode and mean. Now with the median, we're looking for the middle value. Now it's not just as simple as looking along the line and finding the one in the middle. First of all, we need to put them in order of size, smallest through to biggest. Now if I look along the line, I can see that the smallest values are 2. There's 2 of those. Then we've got 1, 2, 3 3s. Then we've got 1, 2 4s. And we've also got 1, 2 5s. And finally we've got a 6. Now just to double check, I know that there are 10 matches, so I should have 10 numbers in my row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excellent. Now what I need to do is find the middle value. So I'm going to cross them off, one from each end, until I get to the middle. Now I've got 2 values in the middle. I need to find the value that is exactly halfway between the 2. In this case, it's very straightforward. We can see that the middle value would be 3.5. And just to double check, I can add the two together and divide by 2, which gives me 3.5, because 7 divided by 2 is 3.5. The range. Now the range is the difference between the biggest value and the smallest. So in this case, if I look at my ordered numbers, 6 is the largest, 2 is the smallest. So the difference between the two is 6 take away 2 is 4. The mean. Now the mean average is when I add them all together and divide by how many there are. Now remember, this is a calculator paper, so if you use your calculator to add them all up, you'll find that you get 37. And we divide by 10 because there are, remember, 10 matches, so there are 10 values. 37 divided by 10 gives me 3.7. Question 13. You can use this conversion graph to change between kilograms and pounds. So we've got our straight line graph, pounds against kilograms. Daniel's weight is 9 stone 6 pounds. 1 stone equals 14 pounds. What is Daniel's weight in kilograms? Well, before we can do anything, we notice on our graph it's pounds against kilograms. And unfortunately, Daniel's weight includes stone. So we need to convert his whole weight into pounds. We're told that 1 stone is equal to 14 pounds. Now, we know that Daniel is actually 9 stone. To get from 1 stone to 9 stone, we multiply by 9, because 1 times 9 gives us 9. We have to do exactly the same on the other side with the pounds. So 14 times 9 gives me 126 pounds. And then we mustn't forget to add on the extra 6 pounds at the end. So Daniel's total weight in pounds is 132. Now if you look at the graph, you'll notice it only goes up to 22. So what we need to do is we need to think of our 132 and we need to find a factor of 132, so a number that goes into it that appears on the graph. Now I know that my times tables tell me that there are 12 11s in 132. So on my graph, if I go to 11 pounds, draw a line across and then down, it will tell me how many kilograms in 11 pounds. And what you'll find is that you get two lines that look just like this. So using my two lines that I've drawn, I can see that 11 pounds is equivalent to 5 kilograms. So 11 pounds is equal to 5 kilograms. Now, I need 132 pounds. And remember that in my times tables, I know that 11 times 12 gives me 132. So 11 multiplied by 12 gives me my 132 pounds. I need to do exactly the same on the kilogram side. 5 multiplied by 12 gives me 60. So the answer is that Daniel's weight is 60 kilograms. Question 14. Now you'll notice that this question is starred. That means the examiner will be looking for well-structured, easy to follow working out. Angela and Michelle both work as waitresses at the same restaurant. This formula is used to work out the total amount of money each waitress gets. So we've got total amount is £6.50 times the number of hours worked plus the tips. The table shows the number of hours Angela and Michelle each worked last Saturday. It also shows the tips they got. So here's our two-way table. Who got the higher total amount of money last Saturday? So that's the question that we need to answer at the very end. You must show clearly how you got your answer. Okay, so let's look at Angela first. So I'm just going to divide the page up so I can do Angela on one side and Michelle on the other. Now, looking at Angela first, if we take our formula, so the total is £6.50 times hours worked plus tips. So For Angela, we've got £6.50. Now she worked 8 hours, and we can add on to that £12 tips. So we need to remember BODMAS, because BODMAS tells us what order to do things in. Here we've got a multiply, but we've also got an addition. So which do we do first? Well, BODMAS tells us to do the multiply before the addition. So what we need to do is we need to do £6.50 and multiply that by 8, and that will give us £52. We will add to that £12 tips, which gives us overall £64 for Angela. Now Michelle, taking the same formula, so we've got total is £6.50 times the number of hours worked plus the tips. That gives us £6.50. Now Michelle, she worked 7 hours. So we're going to multiply that by 7, and we're going to add on the £15 tips, because remember, she got some tips as well. So using the same rule with BODMAS, we're going to do the multiplication first, and £6.50 times 7 gives us £45.50. Remember, you can use your calculator to work that out. And we're going to add on to that £15. So for Michelle, £45.50 plus £15 is £60.50. So that's how much she got in total. The question asks, who got the higher total amount of money last Saturday? Well, looking at our two answers, we can see clearly that Angela got the most money. We need to make sure we actually answer the question. And there's my answer at the bottom with all the working out that I need to get maximum marks. Question 15. Here is a list of all the coins in Amira's purse. So here are all her coins. In fact, there are 16 coins in her purse. We'll need to know that to check our answer at the end. We need to complete the table for this information. So I've got a tally table. I've got my tallies in the middle column and my frequencies at the end. So let's start with the £1 coins. Well, there's one there. Go across, there's another one there. And another one. And that's all the £1 coins. 50p's. Let's see if there are any 50p's in Amira's purse. No, no 50p's. 20 pences. There's one there. Another one there. And another. One there. And there are two at the bottom. 10p's. We've got one there. Another. And one last one there. 5p's. Yes, I can see one there. And one at the very bottom right hand corner. 2p's. There doesn't seem to be any 2 pences, so we're left with the pennies at the end, and we've got one there and one there. So that's our tally column completed. Let's now complete the frequency column. Well, there are 3 £1 coins. There are no 50 pences. There are 6 20 pences. There are 3 10p's. We've got 2 5p's, no 2p's, and 2 pennies at the end. Now to double check, remember there are 16 coins in Amira's purse, so let's add up our frequency column and it should total 16. 3 add 6 is 9, add 3 is 12, add 2 is 14, add the last 2 gives me 16. So therefore I know that I've included all the coins in my table. Question 16. Here is a cube. How many vertices does a cube have? Well, we need to know that vertices are corners. If we're talking about one corner, we call it a vertex. So that would be the singular. If we're talking about lots of corners, we talk about vertices. So that would be the plural. So in this case, how many vertices does a cube have? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8. On the grid, Draw a net of a cube. Well, there's lots of nets of a cube, but probably the most common is the one that's shaped just like a cross. Now, of course, you will draw yours with a ruler, make it much neater. And there we go. That would be a net of a cube. So if I fold that up, it makes a cube. You could have had any of these possible answers. The diagram shows a cube of side 3 centimeters. So here's our cube. It's 3 centimeters long, 3 centimeters wide, and 3 centimeters high. Work out the total surface area of the cube. Now the total surface area is the area of all the faces added together. Now on a cube, we know that there are 6 faces. Now we can either count them on our 3D model here, or if we look back, we can see on our net that we have 6 faces on our cube. Now, if we work out the area of one face, well, it's 3 centimeters long by 3 centimeters wide, which gives us 9 centimeters squared. If we know the area of one face, we can simply take that area and we can multiply our 9 centimeters squared for one face by 6, which gives us 54 centimeters squared. Question 17. Robert and his family are going on holiday to France. A bank gives Robert this chart to help him change between pounds and euros. Robert changes £600 into euros. How many euros should Robert get? Well, we know that £1 is worth 1.2 euros. Now Robert changes £600. So he multiplies the pound by 600. And because he does it to the pound side, he has to do it to the euro side. So 1.2 euros times by 600 gives me 720 euros. In France, a laptop costs 540 euros. In England, the same laptop costs £460. Work out the difference between the cost of the laptop in France and the cost of the laptop in England. You must show clearly how you got your answer. Now, if we take England, we know that £1 is equivalent to 1.2 euros because we get that from the table above. Now, we're told that the laptop costs £460. So we take the pound and we multiply that by 460 and it gives us our £460. Now we do it on the pound side, so we must do it on the euro side as well. 460 is our multiplier, so 1.2 euros multiplied by 460 gives me 552 euros. So that's England dealt with. We're told that in France, the same laptop costs 540 euros. So we can clearly see that the cost in England is 552 euros and the cost in France is 540 euros. So the difference in cost is 552 euros, take away my 540 euros, leaves me 12 euros. So that is the difference between the cost of the laptop in England when we compare it to the cost in France. It's actually cheaper in France. Question 18. Caroline and Mark are in a darts team. The pie chart shows information about the number of games Caroline and Mark each won last year. They also show information about the number of games Caroline and Mark each lost last year. So here are our two pie charts. We've got Caroline's, where they're lost and won games, and Mark with his lost and won games. Caroline played 52 games. Mark played 150 games. Mark won more games than Caroline. How many more? Okay, so we're going to need to deal with each person in turn. We're going to deal with Caroline's games, and we're also going to deal with Mark's games. So let's take Caroline to start with. If we look at her pie chart, we can clearly see that she lost a quarter of her games and she won 3/4 of her games, because the lost slice is a quarter of the whole pie chart, which means that the 1 must be 3/4. So if we take lost, we've got our 52 games in total divided by 4, because we're trying to find a quarter of it. And 52 games divided by 4 leaves me 13 games. So Caroline lost 13 games. So I can write that on my slice, 13 games. Now, if I know that she played 52 games overall, well, if I take my 52 and I subtract 13, that leaves me 39 games. So what I've done is I've taken the total number of games, so my whole pie chart, and I've taken away 13 games, which is how many games she lost. And it leaves me 39 games, which is how many games Caroline won. Now let's move across to Mark. Now Mark's pie chart, I can see that he won 1/3 of his games. So he lost 2/3 and he won 1/3, because 120 degrees is 1/3 of a full circle. And also the slice fits into the circle 3 times. So Mark played 150 games and he won 1/3 of them. So if we deal with how many games he won, well, 150 games in total, if I divide that by 3, it gives me 50 games. So that's 50 games that he won. If he won 50 games, which is 1/3 of my pie chart, then he lost 150 games, take away the 50, which leaves 100 games. So Mark won 50 games and he lost 100 games. Now the question asks, Mark won more games than Caroline. How many more? Well, if we take Mark's games of 50 games that he won, and we subtract from that the 39 games that Caroline won, we get left with 11 games. And that's how many more games Mark won compared to Caroline. So I can write that on the line at the bottom of the answer sheet. Question 19. A picture is made from tiles. The diagram shows the picture in the shape of a rectangle, 120 centimeters by 100 centimeters. It also shows a tile in the shape of a rectangle, 15 centimeters by 20 centimeters. Work out the number of these tiles needed to make the picture. Now don't measure it and see how many times it fits in, because it clearly states the diagram is not accurately drawn. So these aren't accurate sketches. So what we need to do is we need to ask ourselves how many times the 15, the width of the tile, is going to fit in to the 120 centimeters across the bottom of the picture. Well, if I take my 120 centimeters and I divide it by 15 centimeters, it leaves me 8. So I know that 8 of these tiles will fit along the bottom. Now going up the side, I need to ask myself, how many times will the 20 fit in to the 100 centimeters? So how many times will the tile go up the side of the picture? Well, simple bit of division, 100 centimeters, divide it by 20 centimeters, and it gives me 5. So I know that 5 tiles will fit going up the picture and 8 tiles going along. So if I do my 8 and multiply it by 5, it tells me that there will be 40 tiles that will be needed to make the picture. And I can put my 40 tiles just on the answer line. The total cost of the tiles is £52 plus VAT. The rate of VAT is 20%. Work out 20% of £52. So we need to work out 20% of £52. Now we have got a calculator, so we can convert the percentage into a decimal, where we know that 20% is 0.2. So 0.2 times 52 gives me £10 and 40 pence. Question 20. Now notice that this question is starred. Now that means the examiner will be looking for good working out that's well structured and easy to follow. You've got to put everything down that you know. So let's have a look at the problem. DAC, FCB and ABE are straight lines. So there's three straight lines that join together to form a triangle in the middle. Work out the size of the angle marked X. So this is my angle that I'm looking for. You must give reasons for your answer. So that would be why the question's starred, because they want reasons. They want more than just a little bit of working out. So I know when I look at this that this is my starting point. And the reason I know that is because angles on a straight line always add up to 180. So my first reason I'm going to write down is angles on a straight line add up to 180 degrees. So that's my first maths fact. That's my first reason that I've put down. Now that means that the angle ACB is 180, take away my 135, which is here, and that leaves me an angle of 45 degrees. Now notice that I've calculated the angle. I haven't measured it with my protractor because it tells me here that the diagram is not accurately drawn, so there's no point measuring it. So we found out one angle at 45 degrees. Now in the middle here I notice that I have a triangle, and my second reason, my second maths fact, is all angles in a triangle add up to 180 degrees. So angle CBA, so this angle here, well, I know that we've got 70 and 45, and altogether the three of them will add up to 180. So what I need to do is I need to do my 180, take away the 70, and take away the 45, and it will leave me 65 degrees, which will be this angle, because 65 plus 45 plus 70 gives me my 180 degrees inside my triangle. And then I go back to my reason number one, angles on a straight line add up to 180, because here we've got the same situation again. We've got 65 plus something, so my missing angle that I'm looking for will give me 180 degrees. So 180, take away my 65 that I've just worked out, gives me 115 degrees. And 115 degrees is my missing angle. Question 21. The table shows the prices of drinks at Ed's Cafe. So here we've got our drinks, small, regular and large, and our different drinks down the side. Helen buys 2 small black coffees, 1 regular cappuccino and 1 large cola. Helen pays with a £10 note. Work out how much change Helen should get. Well, let's look back. She buys 2 small black coffees. So we've got 2 of those. We've got 1 regular cappuccino, so a regular cappuccino, and 1 large cola. So let's list those. So the 2 small black coffees at £1.40 each gives me £2.80. Then we've got our regular cappuccino at £2.10, and we've also got our large cola at £2.40. So altogether she spends £7.30. So to work out the change, remember you can use your calculator for this if you want to, even to double check. £10, take away £7.30, leaves me £2.70. So Helen has £2.70 change. Ed reduces all the prices by 15%. Work out the reduced price of a large latte. Okay, so let's go back up and have a look at how much a large latte is. So large latte, £2.60. So in my working out, I need to find out 15% of £2.60. And then I need to take it off of my £2.60 to give me the new price, because we're taking it off, remember, because Ed's reducing all the prices. Okay, so on my calculator, I'm going to do 0.15, I'm going to times it by £2.60, and my answer that comes out is 39 pence, or £0.39. Therefore, if I take my £2.60 and I subtract the 39 pence, I'm left with my new price of £2.21. Question 22. Here is a list of ingredients for making 18 mince pies. So there's your ingredients: butter, flour, sugar, mincemeat and egg. Now Elaine wants to make 45 mince pies, and she's got this amount of ingredients. And we need to know, does Elaine have enough of each ingredient to make 45 mince pies? You must show clearly how you got your answer. Well, the first thing we need to think about is we know the ingredients for 18 mince pies. We need to know the ingredients for 45. Now I can't simply double the ingredients for 18 because that would only give me 36. So what I need to do is this. If I know the ingredients for 18 mince pies, I can work out the ingredients for 9 mince pies, because 18 divided by 2 gives me 9, so I can literally halve everything. And from my ingredients for 9 mince pies, I can then work out the ingredients for 45 mince pies, because I know that 9 goes into 45 5 times. So I take my ingredients for 18, I halve them to give me the ingredients for 9, and then I multiply them by 5 to give me the ingredients for 45 mince pies. Now you'll notice that I've constructed a table. For this question, it's a lot easier for me to show you how to do it in a table. So down the side, I'm going to list my ingredients. So I've got butter, flour, sugar, mincemeat and eggs. And in my columns, I'm going to have the ingredients for 18 mince pies, the ingredients for 9, and then the ingredients for 45. And remember, to get from 18 to 9, I'm simply dividing by 2, and then to get from 9 to 45, I'm simply going to multiply by 5. So I need to list what I've already got. I'm not going to worry about the units at the moment. Let's just get the numbers correct. And sugar is 100 grams, 280 grams of mincemeat and 1 egg. Okay, so I'm going to divide everything by 2. So that gives me 112.5 grams of butter, 175 grams of flour, 50 grams of sugar, 140 grams of mince and half an egg. Now I need to multiply everything by 5. So calculator out again, and I should get 562.5 grams. Now I can include the units because it's my final answers. 875 grams, 250 grams, 700 grams, and 2.5 eggs. Now I should say that you could have put units all the way through, but I was a bit tight on space. You'll be able to spread yours out a little bit more. Okay, now the question says, does Elaine have enough of each ingredient to make 45 mince pies? So let's go down the list. So she's got a kilogram of butter. She needs just over half a kilogram. Yes, she has. A kilogram of flour. Yes, she needs just over 3/4. 500 grams of sugar. Yes, she only needs 1/4 of a kilogram, or 250 grams. 600 grams of mincemeat. Now she needs 700 grams. She doesn't have enough mincemeat. She's got 6 eggs. She only needs 2.5. So the problem here is that Elaine does not have enough mincemeat. So the answer to the question is, does Elaine have enough of each ingredient? No. And then I elaborated my answer with Elaine does not have enough mincemeat. Question 23. Mason is doing a survey to find out how many magazines people buy. He uses this question on his questionnaire. How many magazines do you buy? 0 to 4, 4 to 8, and 8 to 12. Write down 2 things. There's a mark for each because it's a 2-mark question. Write down 2 things wrong with this question. Well, the first thing that jumps out at me is we've got 0 to 4 and then we've got 4 to 8. So if I bought 4 magazines, I wouldn't know which box to tick. So we've got overlapping groups. And it's the same for the 8 as well. The 8 appears in the middle group and in the last group. The groups mustn't overlap. And the second thing that jumps out at me is, how many magazines do you buy? Well, there's no time frame. Is it in a week, in a month, in a year? So no time frame. Write a better question for Mason to use on his questionnaire to find out how many magazines people buy. Okay, so something like, how many magazines do you buy each month? And then with our boxes, we can have 0 to 4, 5 to 8, 9 to 12, and then obviously at the end we might get someone who buys 30 magazines. So let's just put over 12 and they'd be able to tick that box. Now you'll notice that the 2 things that were wrong with Mason's question, the overlapping groups and the time frame, I've corrected. I've got how many magazines do you buy each month, so I've given a time frame. And then I haven't overlapped the groups. I've got 0 to 4, then 5 to 8, 9 to 12, and over 12. Mason asks his friend at school to do his questionnaire. This may not be a good sample to use. Give one reason why. Okay, well they're all focused around the fact that his sample is biased. And what exactly does that mean? Well, it means that it isn't a good sample to use because 1, the sample is too small. 2, they could all be boys. So we need some girls really, but we don't know. They could all be boys. And they could be, which they most likely are, the same age. And to get a good representation, you need different ages. So any one of those 3 would get you your mark. Question 24. The equation x cubed plus 2x equals 110 has a solution between 4 and 5. Use a trial and improvement method to find this solution. Give your answer correct to 1 decimal place. You must show all your working. So working out is very, very important in this question. You can see that it's worth 4 marks. So it's an easy 4 marks if we show the correct working and get the right answer. So for this sort of question, trial and improvement, it's good if we draw a table. Now in the first column, we're going to have our value of x that we choose. We're told actually that it lies between 4 and 5, so that's a good starting point for us. Then we're going to cube our value of x. Then we're going to multiply our value of x by 2. We're going to add together those 2 columns. And then we're going to decide, is the value of x too small or too big? Okay, so let's start by putting 4 in, because we're told it lies between 4 and 5, and we can show that in our table by substituting the value of 4 into the x cubed plus 2x. Now remember, we're looking for 110. So you can say this is our target number. We're not going to get it exact, but we need to get as close as we can. So if I put 4 into my x cubed plus 2x, let's put it into the x cubed first. So that's 4 times 4 times 4, which gives us 64. Remember, you can use your calculator for this question. Then we put it into our 2x, which gives me 8. If I add the two columns together, I get 72. Now I'm after 110, so that's clearly too small. Let's put in the value of 5. So 5 cubed is 125. 2 times 5 is 10. Add the two together and we get 135, which is too big. So we've shown here that the value lies between 4 and 5. Now, we know the value lies somewhere in there, so let's try halfway. 4.5. Now 4.5 cubed, if I do that on my calculator, I get 91.125. If I do 2 lots of 4.5, I get 9. And when I add those two together, I get 100.125. And that's still too small. So let's go a little bit bigger, 4.6. Now 4.6 cubed is 97.336. If I do 2 times 4.6, I get 9.2. And then I add those two columns together and I get 106.536. So we're still too small. Remember, all this is our working out. It's all counting towards our 4 marks. So let's try 4.7. Now 4.7 cubed, that's 103.823. 2 lots of 4.7 gives me 9.4. Now if I add those two columns together, I get 113.223. And you can clearly see that that is just too big. So this tells us that our answer for x, if we were to carry on and go further, would lie between 4.6 and 4.7. We need our answer to 1 decimal place. Now we have to decide, are we going to choose 4.6 or are we going to choose 4.7? Well, there are several ways to do this, but the most common method is to go halfway in between, 4.65. Now, if we imagine a number line, we've got 4.6 and 4.7. 4.65, if our answer when we put 4.65 in is too small, then we know that the value of x lies here somewhere, so we're going to choose 4.7 as our answer to 1 decimal place. If when we put 4.65 into our equation, the value is too big, so it's bigger than 110, then we know that our answer will be 4.6 to 1 decimal place, because the value of x will actually lie somewhere between 4.6 and 4.65. So let's put this through our equation and see what we get. So when we cube 4.65, we get 100.54, and then you'll get a calculator full of numbers. Keep those numbers because we can add them to the 2x when we fill in this column. Now when we do 2 lots of 4.65 for our 2x column, we get 9.3. If we add together, remember the full calculator display for this one, plus the 9.3, we get 109.844625. Now we can see that that's just too small. So that means that our value of 4.65 is too small. So the value that we're looking for actually lies in here somewhere. So to 1 decimal place, we're going to choose the 4.7. So the answer that I'd write on the line would be x equals 4.7, which is my value of x correct to 1 decimal place. Question 25. Colin, Dave and Emma share some money. Colin gets 3/10 of the money. Emma and Dave share the rest of the money in the ratio 3:2. What is Dave's share of the money? Okay, so the first thing that I notice here, we've got a ratio, the ratio 3 to 2. And often people don't know who gets the 3 parts and who gets the 2 parts between Emma and Dave. It's literally the order they come in the sentence. So it's Emma and Dave. So Emma comes first. So Emma will get 3 parts. And Dave, he's after Emma, so he gets the 2 parts. So we know that Colin, he gets 3/10. And we've got Emma and Dave. Now, Emma and Dave, they get what's left. Well, if Colin gets 3/10, if we do 1 take away 3/10, we know that that gives us 7/10. So between Emma and Dave, they get 7/10. So at this point, we need to split the 7/10 in the ratio 3 to 2. Remembering that Emma gets 3 parts and Dave gets the 2 parts. Now, I think it's easier if we work in percentage, because sharing a percentage in a given ratio is easier than splitting a fraction. So 3/10 is 30% and 7/10 is 70%. So we need to share 70% in the ratio 3 to 2. So first thing we do is add the parts. 3 plus 2 equals 5 parts. We then share our 70% by the 5 parts, and that gives us 14% per part. So if we go back to our original problem, Emma, she gets 3 parts. But we don't actually need to find out Emma because we want to know what Dave's share of the money is. So let's focus on Dave. So Dave, he gets 2 parts. Now, if each part is worth 14%, so that's 2 times 14%, which gives us 28%. So the answer is simply 28%. Question 26. Solve 3x minus 2 in brackets is equal to x plus 7. So this is what we've got. We've got 3 and then x minus 2 in brackets, and that is equal to x plus 7. So we're looking for a value of x that when we put it into the left-hand side, we get the same answer as if we put the value of x into the right-hand side. Now there's an equal sign in the middle. That equal sign tells me that the equation always has to balance. So whatever I do to one side, I have to do to the other. So first thing we need to do is remove the brackets. So we need to multiply out the brackets, remembering that whatever's on the outside is multiplied by both things inside, the x and the minus 2. So 3 times x is 3x. 3 times minus 2 is minus 6. And that is equal to x plus 7. Now we've no brackets on this side, so there's nothing to do there. Then what we need to do is we need to add 6 to both sides. We're trying to leave x on its own. So let's add 6 to both sides. Now minus 6 add 6 disappears. It's nothing. It's worth 0. That leaves us 3x on the left-hand side. On the right-hand side, we've got x. Now plus 7 add 6 is 13, because 7 add 6 gives us the 13. Then we need to subtract x from both sides. So x take away x is nothing, it disappears, so we're left with 13 on the right hand side. Now on the left hand side, 3x take away x is 2x. Now 2x is equal to 13. So what we need to do here is we need to divide both sides by 2. Now 2 divided by 2 is 1, and that leaves me my x on its own, and 13 divided by 2 is 6.5. So my value of x is x equals 6.5. Question 27. XYZ is a right-angled triangle. Now it's significant that it's right-angled. Calculate the length of XZ. Give your answer correct to 3 significant figures. So we're needing to calculate the length xz. So that's the longest side, and in triangle terms, the longest side of a triangle is called the hypotenuse, and it's always opposite the right angle. Now the fact that there's a right angle in this triangle and we're looking for the length of one side and we know the other two, we should be thinking Pythagoras' theorem. Now the first thing we need to do is we need to label the triangle, and I'm going to call the longest side A and the other two sides B and C. It doesn't matter which way round those two are. Now Pythagoras' theorem, you may have seen this formula. A squared equals B squared plus C squared, and A squared is on its own on the left side of the equal sign, and the letter that's on its own is always the longest side. So what we need to do is substitute the values that we know, the 1.35 and the 3.25, into my equation. So I have A squared and I've got 1.35 squared and 3.25 squared. So A squared is equal to 1.8225 plus, and 3.25 squared is 10.5625. Of course, for those you can use your calculator, and remember you're looking for a button that looks like that. So A squared is equal to 12.385. Now I need to undo this squared to give me A on its own. Now the inverse of squared is square root. So you may have it on your calculator on a button and it probably have a little square underneath, or it may be above the squared button. It depends on the type of calculator you're using. But what we need to do is we need to square root our 12.385, and that will give me my value of A, which turns out to be 3.52. And then I can put it on the line at the bottom, 3.52, and my units are there as meters. If you found this past paper useful, please like and subscribe.